Hello students, welcome back to Organic Chemistry. In this video, I'm going to solve a question wherein we are going to do a series of reactions to convert the reactant to the final product. In order to convert benzoic acid to tribromobenzoic acid, we need to follow the methods given here. That means what? You can see that there are 5 reagents or 5 reaction conditions given here. We need to strictly use only 5, not more than 5, less than 5. What reagents are we supposed to choose? That is given over here. There are 15 reagents given, right? So you have to choose among all these and do the proper conversion. Now, whenever you look at the reagents, you should know what sort of reactions they do. For example, HNO3 H2SO4. So it is used in nitration of benzene. What about methyl chloride and aluminum chloride? It's nothing but Friedel-Crafts alkylation. In this case, methylation. Like this, you should be knowing what is the purpose of these reagents. Only then you can solve such questions. Okay. So let's get started here. So let me start with the benzoic acid. If you take benzoic acid and do the bromination, the bromine always goes to the meta position because COOH is a -R group. Therefore, it is a meta directing group, right? So we don't want the bromine at the meta position. So the first step is definitely not bromination. Somewhere we have to do the bromination because there is a tribromo, right? So, but not in the first step. And also the COH is a -R group. That means what? It is electron withdrawing group. When it is electron withdrawing group, the benzene will be electron deficient. So the attack of the electrophiles will become very difficult. So what we will do is first we will introduce a group which is electron donating so that the benzene will become electron rich. Further, it will undergo electrophilic substitution reaction like bromination. And if you look at the reaction conditions, there is a methyl chloride, AlCl3, which is a Friedel-Crafts alkylation, which can increase the electron density on the benzene ring. But it's very difficult to remove this methyl also at the end of the reaction because you don't see any carbon over here. The best reagent we can use here is HNO3 H2SO4 because it is a nitration, and you know that nitro can be converted to NH2. NH2 is easy to remove through the process of diazotization. So like this you have to think way ahead. Only then you can solve such questions. All right. So anyway, now since it is a meta directing, you know that the nitro group will go to the meta position. You write either here or here, won't make difference. It's the same. All right. So this will become our reagent P. What is P? Look at the value. HNO3 H2SO4, the value is 1 because once you substitute all these values, you have to answer this way. Like you have to add and subtract the particular reagents to get the right number. That is the reason. All right. Now, I have to reduce this nitro to amine because amine is an electron donating group. That's what I told you, right? We have to introduce a electron donating. Nitro is also electron withdrawing. So we need a reducing agent like lithium aluminum hydride or hydrogen in presence of a catalyst. So here we have only this as a reducing reagent, appropriate reducing reagent, right? So this will become our Q, and what is the value of Q? It is 6. While you write the reaction, it's better to write down the values also, right? So now this will become NH2. Now NH2 is an electron donating group. Why so? Because the lone pair of electron on nitrogen will be given to the benzene to increase the electron density. Now let's do the bromination. So bromination, bromine in water will provide more and more bromonium ions. That means what? It will undergo bromination thrice. But where it will go? So let's see that with respect to NH2. Right? It's a ortho para directing, which is ortho to this carbon. This is ortho, right? To this carbon I'm talking, and para to this here. So the bromine will go here and then here and then here. Yes, you can see it's something what is there in the final product. Now we have COH and 3-bromine, but we don't want this NH2, right? It's very easy to get rid of NH2. How to do that? By diazotization. But before that, first let's see what is bromine here. It's R and the value is 4, right? And then now, as I told you, diazotization. This is very important reaction. If you observe in the previous year question papers, some or the other question directly or indirectly, you will come across this, okay? So 0 to 5 degrees Celsius, right? So you are going to get a diazonium salt, N2Cl. What about the rest of the groups? Untouched. They should not change these groups, okay? The reaction condition used here. Now, what is this? The value of this is 5. So PQR, S is what? 5. Now, we have to get rid of this by substituting with hydrogen, and the best reagent here is H3PO2. What are the applications of the diazonium salt? You have to remember, okay? How to replace this N2 by H, by chlorine, by say OH, all these conditions you should memorize, all right? So what is the value here for a T? The T is 13, right? So H3PO2, it will substitute the N2 by hydrogen, nothing but the final product what is shown here, right? If you want, you can ignore this, okay? It's understood that there is a hydrogen, right? So this is our final product, that is tribromobenzoic acid. So these are the steps involved. Now still we are not done with the final answer. You're supposed to solve for this. What is the p value? 1, q value 6. R, they are giving 2 times of the R, that means let's write 8, right? 4 multiplied by 2, and then S is 5, right? And then subtract 13. Okay, so let me just, okay, 13. Solve for this, you're going to get 20 minus 13, nothing but 7. Yes, the final answer is 7. So this is how you have to do the series of reactions. You have to think way ahead and then predict the reagents. Thank you for watching this video.